Thank you for joining this lesson. We're going to study the application of calculus in kinematics, number 24 of the paper. The displacement s in meters of a moving particle from point O after t seconds is given by s equals to t cubed minus 5t squared plus 8t plus 7. Find s when t is 3. So finding s when t is 3 and the function of s has already been given, then we will directly substitute t with 3 and say we'll start with 3 cubed minus 5, 3 squared plus 8 into 3 plus 7. Therefore, this is going to be 27 minus, this is 9 by 5, 45 plus 24 plus 7. And this is going to give us exactly 13 meters. Part B. Determine the velocity of the particle when t is 4. Therefore, velocity is usually given when we differentiate the distance function with time. And this is going to be when we differentiate this distance function, we drop the power here so that we have 3. Then t, which was to power 3, now becomes power 2. Then we drop again power 2, making this one 2 by negative 5, making it a negative 10. Then t, which was squared, now becomes power 1 plus 8. Remember, t is to power 1, so 8 remains as it is. And t, which was to power 1, now becomes power 0. So that is why t disappears, and the constant in this case now has also to disappear because it is being multiplied with the t power 0. So it disappears. So now we're going to have the value of v calculated when we substitute t with 4 squared, 4 plus 8. So this is going to be 16, making it 48 because of 3 minus 40 plus 8. And this is going to be 8 plus 8, 16, because it is velocity, meters per second. Then we have a part 2, the values of t when the particle is momentarily at rest. To be momentarily at rest is to have a velocity of 0. Therefore, we're going to have the velocity function equated to 0. 3t squared minus 10t plus 8 equals to 0. Therefore, for us to solve this one, I choose the quadratic formula, whereby t will be given by the negative value of b plus or minus the square root of b squared minus 4ac divided by 2 times a. Therefore, we're going now to make use of this formula. B is negative 10. So negative 10 plus or minus the square root of b squared. It is negative 10 squared becomes 100 minus 4 into a, which is 3, and c, which is 8, then divided by 2 times 3 because a is 3. So now we're going to have this one as 10 plus or minus the square root of 100 minus 24 by 4 is 96. So 100 minus 96 is 4 divided by 6. So we can get the two values of t by saying t is either 10 plus the square root of 4 is 2. So making it 12 out of 6, or t equals to 10 minus the square root of 4, which is 2, which is going to be 8 out of 6. So when we divide, this is going to be 2, or t equals to, this is by 2, 4, by 2, 3, 4 out of 3, which is 1 and a third seconds. So these are the values of t when the particle is momentarily at rest. Part C, find the time when the particle is moving at maximum velocity. So we should know that at maximum velocity, at velocity maximum, acceleration is always 0. And how do we get acceleration? By differentiating velocity with time. So this is going to be the velocity function, which is here, can now be differentiated with respect to time. So we'll have our t, which is squared. We drop the 2 here, and we have 60 minus t power 1, we drop the 1, negative 10, and t disappears, and also the constant part disappears. So we want to get t when the particle is at maximum velocity. So at maximum velocity, acceleration is 0. So acceleration function is already calculated. So 6t minus 10 should be equal to 0, and 6t should be 10. So 6, we divide through by 6 to remain with t. So 10 out of 6. When we simplify this, we have 5 out of 3, and the value of t is going to be 1 and 2/3 seconds.